In the last video, we designed the handshake flow between server and the client. In this video, we will inspect all the packets between server and client using Wireshark. With the Wireshark, we would be able to monitor all the packets going server to client and client to server. So let me log into my server and start the null-talk server. So first I will SSH into my server. My server is running on the IP address 10.18.24.95. So I'm logged into my server and I will simply start this server by running the binary. Okay, so TCP server is listening on the port 8080. Now I will open another terminal and I will run a client which will try to connect to this server, and we will monitor the handshake packet using Wireshark. So let me apply some filters. First we will listen for EN0 interface. Fine. There are a lot of packets going on, so we will apply the IP address filter, and IP address equals to 10.18.24.95. So now we will get all the packets including this IP address. So server is running and I will run the client as well. So anti-client host is going to be our server address 95 and the port is going to be 8080, and I have to provide the key path which is our RSA key, and I will use this one which is present in .ssh id RSA. Okay, so the client is connected successfully, and on the server as well we got the log that new client has connected with the name ID RSA. Okay, perfect. And we did capture some packets in the Wireshark. So first, in the TCP, to establish the TCP connection, we have a three-way handshake in the TCP itself. So our client is running on the port 654 and the server is running on the port 8080. And the server has the address of .95, it is ending with .95, and the client is .89. Yes, both the devices are on the same network. So first the client sent the SYN packet to the server. Server is sending SYN and acknowledgement packet, and the client is again sending the acknowledgement packet. So at this point, our TCP connection is established between our client and the server. Now, after the TCP completion, the client will send us the public key. So the packet type is push, and the client is sending to the server. And if we check the payload includes this ID RSA and the public key text, as you can see. This is the complete public key. In the next packet, server is sending the acknowledgement to the client, and the server is also sending the nonce to the client. Client acknowledges the nonce. Now client will sign the nonce with the private key, and it will send the signature to the server. So in this packet, we are sending the signature to the server, and the signature is also some random bytes only. Now server receives the signature and pushes the session key to the client. Client receives the session key, and again session key is some random byte, 32-bit, and session key is encrypted with the public key. So nothing is visible here. Session key is completely encrypted. client acknowledges the last packet sent by the server. So this is the complete handshake flow between client and our server. In the next video, we will check out the DM handshake and all the packets.